Okay, chapter 2 is called Solving Linear Inequalities, and 2.1 is Writing and Graphing Inequalities. Okay, so first some inequality symbols. Less than or fewer than is going to be this symbol. That's how you'd say that out loud, right? And greater than or more than is going to look like this. Okay. If it can also be equal to, then we're going to take these two symbols and underline them. So less than or equal to would look like that. You could also say it's going to be at most something, or no more than. And then greater than or equal to is going to look like that, or is at least, or is less than. Okay. All right, so we're going to take some sentences and rewrite them as inequalities then. So here we have 7 more than a number is less than or equal to 5. So 7 more than a number. Well, a number, means it's an unknown number. So you could use, we're going to use a variable. You could use any variable you want. I'm going to use x. That's the one we'll use most commonly. 7 more than that would be x plus 7, right? I've got a number and I've got 7 more than that number. And then it says it is less than or equal. So that's where I want to choose the right symbol here, less than or equal to. That's going to be this one, okay? And then 5. It's less than or equal to 5. So there's my inequality, okay? We're not asked to solve this. If you're asked to solve it, it would mean isolating the x. But that's coming later. Right now we're just taking these sentences and writing them as inequalities. Okay, so twice a number minus 3 is greater than 6. Okay, so I've got is greater than. So is greater than, that's going to be this one. Okay, is greater than 9. So that's that piece of it. All right. This piece causes a little bit more problems because it's a little bit more complicated. So we've got twice a number. So let's just start with twice a number. Well, if I'm saying a number is x, that's my unknown number. Twice that would be 2x. And then minus 3. There we go. So twice a number minus 3 is greater than 9. Okay. All right. So sometimes you'll want to check if a number is a solution to an inequality. And to do that, you're going to take whatever number you're checking and substitute it into the equality where the x is. And you'll either get a true statement or a false statement. Okay, so if it's true, it's going to be a solution. If it's false, it's not a solution. So this says to check whether negative 6 is a solution. So I'm going to take negative 6 and substitute it in where the x is. So I replace the x with negative 6. And now I'm going to simplify this a little bit on the left. Negative 4 plus 6 would be negative 2. Okay, and then I'm going to decide if this is true or not. So if I read this out loud, it says negative 2 is less than negative 1. That is true. Negative 2 is going to be to the left of negative 1 on the number line, right? You'd rather have negative $1 than negative $2, right? So that means negative 2 is less than negative 1. So this is true. Because, that's not my final answer. It's a true statement, and that means that, yes, it's a solution. Okay. All right, so let's try negative 6 out here on this one. So I'm using substitution again, and I've got a double negative here, right? Because I'm subtracting x, and I replaced x with negative 6. So I've got a double negative there. So when you're subtracting a negative, that's the same as adding a positive. So I could rewrite this as 3 plus 6 then, okay? And 3 plus 6 is 9. So this says 10 is less than or equal to 9. And that's false, right? 10 is more than 9. It's not equal to it. It's not less than that. This is a false statement. And that means that, no, negative 6 is not a solution to that inequality. Okay. All right, next page. When graphing inequalities on a number line, we're going to use an open dot if you've got one of these symbols. And we're going to use a closed dot if it's one of these. Okay. So looking at this first inequality here, it says x is less than 3. So hey, I'm going to use an open dot there. So above the 3, I'm going to put an open dot. Okay? And then I'm thinking about all the numbers that are less than 3. And would that be to the right of that dot or to the left? And they're going to be the left, right? All of these numbers to the left of 3 are less than 3. So that means I can represent my inequality like this. Okay? So this means that the number 3 itself is not included in this group. It's everything up to 3. 2.999 is part of that group, but 3 itself is not. Okay? Since this one says it can be equal, that means I'm going to use a closed dot. So usually what I do on these ones, first I just look at the number, which is negative 2.5, and then I think open or closed dot. So this one's a closed dot, so negative 2.5 would be right here. So, you could draw these number lines right on, I could have drawn this right on the number line itself. Some people do that, but I don't like to do that because then sometimes it's hard to tell if it's an open or closed dot if you put it right on the line. If you have it float above, it's a lot easier to tell what we got going on. Okay. Now this one's a little tricky because a lot of people are going to look at that arrow and say, oh, I'll just make an arrow going to the left, kind of like here. We had an arrow going to the left, and so we got an arrow to the left on our number line. But that's not actually the case. On this one, the variable was on the left-hand side of the equation. So this says negative 2.5 is less than or equal to y. And that actually means that the y's are going to be greater or equal to negative 2.5. Okay, so I could take this whole inequality and flip it around. So I could put the y on the left and the negative 2.5 there, but then I also have to flip this symbol. Okay, so if it's helpful, you can do that, and if you have the variable on the left, then you can just follow the direction the arrow goes. Okay, so this says y is greater or equal to negative 2.5, and maybe that's easier to read. That's easier for me to think about that way. So all the numbers that are greater than negative 2.5 are going to be to the right of that point. Okay. All right, and now we're going to do this in the opposite direction. We're going to write an inequality for each of these graphs. So here I can see this is called the dividing point is negative 4. So that's kind of what splits the world in two there. Here the dividing point's 3. Okay, so this dividing point is going to be included because that's a closed dot. So I'm going to use x here, but you could use any variable you want. Okay, and x is going to be numbers greater than 4, and I want to negative 4, and I want to include the negative 4 as well. So that's why I have that that underlined symbol there that says x is greater or equal to negative 4. And there's my inequality. Okay, with this one I'm going to use x again. I'm going to have numbers less than 3, and 3 itself is not included, right? So I don't have the little, it's not underlined because it can't be equal to 3 itself. It's just numbers less than 3, okay? All right, that's the end of the section, and I'll see you next time.